So now we're going to talk about a topic called predicates. So let's start with the definition. There are two terms we're going to look at right now. The first one being, what is a predicate? A predicate is a sentence that contains a finite number of variables and becomes a statement when specific values are substituted for the variables. So again, a predicate, it's a sentence that contains a finite number of variables. When I plug in for those variables, it becomes a statement. And remember, a statement is something that's either true or false. So our second definition, and we're going to look at an example after this, but let's look at the second definition. The domain of a predicate variable. It's much like a function. It's the set of all values that can be substituted for that variable. So the domain consists essentially of all your possible input values. So let's look at an example. Let's look at the predicate P of X. It's going to be the predicate x squared is greater than x. That is a sentence, and if I plug in a value for x, it would either be true or false, so it would be a statement. And then anytime you look at a predicate, you need to be given the domain. So I'm going to tell you with domain, the set of all real numbers. Remember, the way we represent that set is with an R. So what I want us to do is write P of 2, P of 1/2, and P of negative 1/2. And out of these, I want you to determine which are true and which are false. So let's start with P of 2. I'm going to plug in 2 in place of x. So then it's going to say 2 squared is greater than 2. Or you could write this as 4 is greater than 2. And then you've got to decide, is that true or is that false? Is 4 greater than 2? This is true. Now let's plug in 1/2 in place of x. 1/2 squared is greater than 1/2. 1/2 squared would be 1/4. Is 1/4 greater than 1/2? That is not true. And so this would be false. And finally, if we look at P of negative 1/2, it would say negative 1/2 squared is greater than negative 1/2. If you simplify this, it would say 1/4 is greater than negative 1/2. Well, positive numbers are always greater than negative numbers. And so this would be This would be true.